Today we're going to take a look at section 10.2. 10.2 and 10.3 legitimately are like just one giant section that they've sort of split because it was too much material. So this is called displaying data part 1, and the other one's going to be called part 2. So to start with, we're going to take a look at a number of different kinds of graphs, and the first graph we're going to look at is called a pictograph. So in a pictograph, we use pictures to represent tallies within a category. Kids use this really young. So I remember even last year when my son was in 2nd grade, they were doing pictographs. So these occur at a pretty young grade level. We're going to do a maybe not so applicable problem to that grade level with our first example. An Automobile Club of America considers holiday weekends to start at Friday at 6 p.m. and last until Monday at 6 p.m. If 150 people died on such a weekend by 6 p.m. on Saturday, 80 people from 6 p.m. Saturday to 6 p.m. Sunday, and 100 from 6 p.m. Sunday to 6 p.m. Monday, draw a pictograph of the data. So this would probably be not the presentation section you would want to go with on this for the 2nd grade classroom that you're teaching in, or whatever. But all right, so what we're going to do is we're going to draw rows to represent the 3 different time frames that they're talking about. And I know they're measuring from 6 to 6, but basically they're talking about Friday night, Saturday night, and Sunday night. Okay, does that sound right? Starts Friday at 6, so it's Friday to Saturday, Saturday to Sunday, and Sunday to Monday. So I'm going to I'll call it that way, in fact. This is the Friday, Saturday time slot. This is the Saturday to Sunday time slot. And this is the Sunday to Monday time slot. Now I have to use the data values that they give me. And the data values I see are 150 people the first day. Looks like 80 people the 2nd day and 100 people the 3rd day. So those are the 3 different values that I have to use, but I want to draw pictures that represent the information. Now, when kids are doing this, first of all, it's just one picture they'd have one picture for one person, but obviously I don't want to draw 150 pictures of anything. So I'd like for my tallies, my pictures, to represent more than one person. So there's a couple of different ways we could do that. We could either there's lots of ways we could do that, but there's a couple that are nice, really nice. We could either let whatever image we use represent the number 10, which would be good because all of these numbers are divisible by 10, right? Or we could let it represent 20 because then I don't have to draw as many pictures. I'm going to draw it with the 20 so I can show you what would happen if you actually choose something that's not evenly divisible, because the 150 on here is obviously not divisible evenly by 20, right? But I can still use 20 to do it so I don't have to draw quite as many objects. So we're going to use, for fun, a heart. Because we love these people that died, right? Even though they died, they're still loved, right? Okay, so my heart is going to represent 20 people. So let's go with the 150 first. How many whole hearts am I going to draw to represent my 150 people? 7. So draw yourself 7 hearts. Now, I just drew 8 because I'm going to erase half of one, and I have a half of an image at the end. So if you're going to do that, you need to pick whatever shape you are going to do that it makes sense to draw half of it. Like if we chose to do squares for my shape, which would be fine in general, you have to draw the square in such a way that when you erase half of it, it doesn't still look like a square. And that's difficult with a square. Like if you were really actually doing a square like this as your image, it would probably be best to erase the image like this so that when I draw and connect the pieces, I can actually tell that I don't have a whole square. Because if you split it horizontally, right, like this, it's harder to see that you don't have your full image because it's still a square-ish shape. And none of us are going to be super precise as we're drawing these, and we all recognize that fact. Okay, so I have 7.5 hearts here. That's my 150 people. What am I going to do? How many hearts am I going to do for 80 people? Yeah, 4. And how many hearts am I going to do for my, what do I have left? 100 people. 5. Now, one thing that I can kind of do easily by default because I'm doing a copy-paste is that, do you notice all my hearts sort of line up? So if I have 5 in one row, they should match with the 5 I have from the next row. I want to make sure that all my images are, at least visually, as you're drawing them, the same size, the same shape, that they're lined up vertically to match. I don't want to look at one row and actually physically have to count them to know that there were more on Sunday, Monday than there were on Saturday, Sunday. I should be able to see that very easily, and having things lined up and organized helps with that. Now there's one more thing that we need on this graph. Anytime we're drawing a graph, our graph needs a title. I don't care really where your title is, title at the top, title at the bottom, title on the side, but it needs to be there. The title just needs to describe what in the world this is a graph for. So what is this a graph for? Yeah, it's the number of deaths. This is the deaths on a holiday weekend. Where my heart equals 20 people. So somewhere on there I need a title, and somewhere on there I need a key as well. Heart equals 20 people. That has to be included at some point somewhere. It doesn't necessarily have to be in the title. A lot of the cases we won't actually even have a key to draw in, and so obviously it won't be in the title. But as long as the key part of it is somewhere on there, we're good. Yeah. Any questions about the pictographs? Okay. Next type of presentation or type of graph then is called a dot or a line plot. This is a really quick way to display data with fewer than 50 values. And we're going to do an example of weights for children. This example is fine. You'll notice it's in kilograms, right? And that might not be very applicable in an American classroom. Or maybe you want to have more of an emphasis on the metric, so it is applicable. Okay, so this would be sort of one of those that you could probably use this in an actual classroom and it would make sense. The mass in kilograms of each child in Mrs. Good's class is as follows. We've got a whole collection of data, and we want to make a dot plot for the data. So here's the way we make a dot plot. First, you're going to draw a horizontal line, and you need the smallest value and the largest value, at least, marked on that line. So what is the smallest value? In all of that data, which numbers are smallest? 39. And which number is our largest? There's a 49. So I need a smallest value and a largest value. And the reality is I need at least a hash mark for all of the others as well. I didn't mean 48 there. I have no idea why I wrote that. It's 39. So I'm going to make a hash mark for everyone. I don't necessarily have to write the number down for each of them, but I do need to have a location marked for them. So this would be 40, 41, 42, 43, 44, 45. I'm going to mark a few of them in there so I can have a reference. 46, 47, 48, and 49. So at the very least, you need a few of them marked. If it makes you feel better, mark them all. That's totally fine too. It won't hurt anything. Okay, so there's my axes. And then, let me make a comment since I made it here. They should be roughly spaced evenly, okay? So we shouldn't have it looking like 39 and 40 are really close together and then 40 and 41 are far apart. I mean, it needs to be evenly distributed. And what we're going to do is we're going to put a little X above the line for each data value. For example, here's the number 40. So at the number 40, I'm going to put an X right here. And we're just going to mark them off as we go. 42. So at the height of 40, or at 42, I'm going to put an X. Again, the X should be about the same size as the first X at about the same height. And then I have a 49. So the 49, about the same size and height. And then a 41. I have a 42 and a 43. Okay, so 42 now, that's the second 42 that I've had, right? So what do you think I might do? Yeah, I'm going to stack it above. So there's another 42. I have 48 and 39. 46, 41. So 41 stacked. 42, 40. 42 is now 3 high. 49, 45. 39, 43. 47, 44. 49, 42. All right. You don't necessarily have to have an X in each number slot. This one did, but it wouldn't have to. So it'd be okay if you had some that had blanks above it. There just wasn't anything there. Any idea what else I might need on this graph? A title. Right. So what is this graph giving me? Yep, the mass in kilograms of children. What children? Yeah, in Mrs. Good's class. And while the data is totally made up, Mrs. Good was actually a teacher I knew. She was my daughter's pre-K teacher. It's a good name to have, right? It is. All right. Our next kind of graph is a stem and leaf plot. This is akin to the dot plot, similar to, but it's drawn vertically instead of horizontally. The numbers on the left are called stems, and the numbers on the right are called leaves. You ready to take a look at one? All right. We have some grades from a first exam. We're going to make a stem and leaf plot for these grades. Now what we're going to do is we're going to draw a vertical bar. And again, I need to know what my least and greatest numbers are from the data. So what is my least number? 43. And my greatest? 94. So all of my grades range in the 40s to 90s on this exam. So I'm going to put a 4, 5, 6, 7, 8, and 9 on the left-hand side of the bar. Now, I'm going to do one that's like scratch work, kind of what you would do, and then I'm going to draw one that's actually the final answer. What I need is each one of those data values written on the appropriate row. For example, I have the number 87 right here. 87 will go on the row that's got an 80 in it, and I'll write a 7 as the leaf. And then we have a 76. So the 76 will go on the 70 row, and I'll write a 6 right next to it. Okay, so I'm just going to write in all the leaves on the correct row that they're supposed to be on. So 94 and 58. So here's 94, and here's 58. 82 and 43. 89 and 53. 67 and 80. 90, 94. 74, 77.
I think you put the 80 0 on the 7.
Did I?
Yeah. There's not a 70, so that's 0.
Thank you. Okay, let me try that again. The order doesn't really matter right now anyway, so that's fine. Thank you for catching that. I did a 74 and 77, right? 87, 74, 89, and 90. Okay, did everything else get in the right spot? I think so. Everybody good? Okay. So what do I need next? Well, what I really need is I need all those leaves to be in order. And because I just did it to make sure I caught them all, I wasn't worrying about that before. So my next graph is going to have the same data on it. I'm just going to put the leaves in order. The stems are already in order. 4, 5, 6, 7, 8, and 9. And they'll just go from smallest to largest. So 43, of course, is the only value, but then I have 58 and 53, so 3 comes before 8. As you're writing these in as well, your rows should line up. So if you have 2 digits on one row, it should be the same sort of length as 2 digits on another row. So 7. On the 70s row, I have 2 4s and then a 6 and a 7. So 4, 4, 6, 7. The 80 row, I have a 0, 2, 7, 7, 9, 9. And then I've got 0, 0, 4, 4 on the 90s. Okay. So this is my answer here on the right. So if you want to be like more careful when you create it to begin with, so you don't have to create it twice, you can try that. You might miss a data point and have to do some erasing, but you could do that. But your final answer should have them in order from least to greatest. And what am I missing at the moment? A title. So what is this? Yeah, it's grades from a first exam. Now, we know what we did to create this, but if you were just given this and you didn't know what a stem and leaf plot information gave you, this might look pretty confusing. I just see some numbers everywhere. I don't know what any of the numbers represents. So we're going to write that into our key, where, and you can use any of the numbers you'd like, but I'm going to use this one, 8/0 is a score of 80. Or use whatever other 2 numbers you want, okay? That tells us what the left and the right actually mean in terms of the scores of a test. This actually is data from a first test that I created, or that I gave a number of years ago. Okay, so continuing on with the idea of stem and leaf plots, there are also something called back-to-back stem and leaf plots. These are actually 2 stem and leaf plots that are sort of put together. One of them ends up having the leaves on the right, and one of them ends up having the leaves on the left, and they share the stem column in the middle. Now, as we're doing this, we're going to use the data we already created as one of our data sets, and we're going to have a second data set as well. These are the grades from the second exam from the same class. So what I want to do first is I want to create the individual stem and leaf plot that this data represents, and then I'm going to do a second step to combine the 2 stem and leaf plots together. Sound good? Okay, so take a look for the smallest value and the largest. What's your smallest? 64. And your largest? 99. There it is. So I actually need to start at 6. I'll do 7, 8, and 9. And we're going to write all our data down. So I have 93, 96, 98, 66, 67, 82, 92, 85. Right now it doesn't matter if things line up because we're just scratch working it, right? 64, 81, 86, 72, 96, 95, 99, 95, and then 94, 74. Okay, now when I combine these two stem and I know they're not in order yet, we'll get that, but when I combine these two stem and leaf plots together, they share the same stems. So on the other graph, I actually had stems that went all the way to 4, right? So my stem and leaf plot will have to start with 4 because I've got to have both sets of data on them eventually. So I'm going to do 2 vertical bars, and it will have the numbers from 4 to 9 in between them. Now, just numerically speaking, or chronologically speaking, that first exam probably should go on the left, and the second exam should go on the right, because they just happened in that order. So let me actually stick on the screen for the moment, and we'll do the right-hand side, the second exam side of our data. And then I'll go back and catch or gather the other one. So on the 60s column, I have 6, 7, 4, so that's 4, 6, 7, right? And on the 70s column, I have 2, or row, I have 2 and 4. So I'm making sure to line these up now. In the 80s row, I have 1, 2, 5, 6. And then in the 90s row, I have a lot. 2, 3, 4, 5. 6, 6. Ah.
2 5s.
Oh, thank you. I didn't catch both 5s. Okay, I'm going to move mine over just a little bit. I'm running out of space. 2 5s, thanks. And then 2 6s, I think. And then 8, 9.
Yeah.
Did I get them all? Now, I'm going to copy paste my other data set and I'll manipulate it, but here's my data set from before. Oh, I had it in order and I copied the wrong one, didn't I? Okay, hang on, let me get the other one that had it in order. There is such a thing as too small to read. Okay, we'll go with that. I have these numbers. Now, what I want to do is I want them to go in order now from the center moving out, so they'll all reverse direction. So like the 4, 3 would be a 3 now on the left-hand side of the 4. And then I have 53 and 58, so it'd be 53 with the 3 beside the 5, and then 58 moving outwards. Does that make sense? I'm just switching all the orders around. I have 4, 4, 6, 7 moving outward, so I have 4, 4, 6, 7. Whoops, you're right. The zooming in and zooming out makes it hard to keep track a little bit. So there's 67 from the 60s row. On the 80s row, I have 0, 2, 7, 7, 9, 9. And then on the 90s row, I have 0, 0, 4, and 4. Okay. Thoughts? The second test did go a lot better. Yes, indeed. And you can say that by a couple of things. I mean, you could notice that there's no 40s and 50s, but you can also notice that the length of the A's is considerably longer. Those are not necessarily both things that happen every time. I mean, we still could have ended up with better grades, but they don't all end up being A's, right? And they could have all been C's.
Do you give this like a double title, like where the grades from the first grade?
It's a good question. We do need a title, and so it's going to have one title, but we're going to write it combined. So it's going to look something like this. These are the first and second. If you want to say first on the left, you could do that. And second. Exam scores. We still need to do what I did in the last one where I said where and give it a key. 8/0 is a score of 80.
Would you specify like a 3-4 how it's backwards, or?
I haven't ever seen them do it in that way. At this point, you know, in order to kind of understand what the back-to-back stem and leaf plot is, you kind of have to have a reference point from the regular stem and leaf plot. I've only seen them reference it the way that I've written it down. I've never seen a reference point otherwise. But I do understand sort of the question, Amy, of what about the left-hand side and how do I think about that side? But I've never seen it referenced any differently than this. Yeah. All right, we've got just a few more that we're going to look at today. A grouped frequency table is the next one. This kind of feels like a tally chart. All right, so this shows how many times data occurs in a range or class, a range of classes or intervals. So it looks like a tally chart, but what happens is that the data is combined in sort of a category. And in some sense, what we did on our back-to-back stem and leaf plot, it kind of or even our regular stem and leaf plot, it kind of is like that too, right? So one row isn't the score 80, it's the score of anything in the 80s, right? So we're going to actually draw a grouped frequency table using that same information, and we're going to use it from our second exam. So using the data from the second exam and the standard grading scale, right? Standard grading scale means like 60 to 69 is a D, right? Make a grouped frequency table showing the letter grade disbursement for the grades on the test. Now, it'll help me if I just copy, and you guys can just reference by looking back at, this is what happens when you do too many erasings. Those of you who, yeah, that will work. Okay, I think I got it. Who've done presentations before know that I don't like the erase button, and I've been using it a lot today. All right, so what this actually looks like as a reference point, since I've put that here, is that you're going to draw a table with 3 columns. The first column is going to be the class intervals. In this case, they're grades. The grade interval, we'll call that grade interval. The column in the middle is the tally column. And then the column on the right is the frequency column. Now we have the benefit in this one of having already made our stem and leaf plot. If you didn't, the tally column is much more evidently like necessary than it is at the moment. Let's get our grade intervals and then I'll show you what I mean. So in this data set, the lowest grade is in the 60s, so I do need a 60 to 69 range. And the highest grade is in the 90s, so I'm going to go up from there. So this is 70 to 79. 80 to 89, and then we really have 90 to 100, but so that our intervals are the same width, and because it doesn't matter on this one since we don't have a score of 100, we're going to write 90 to 99. Now literally what I would do if I didn't have my stem and leaf plot that I just copied over is I would go through this and I would make tally marks. Here's 93 and 96. That's 2 scores in the 90s, 98 and 66. That's 3 scores, so one more in the 90s and one more in the 60s. And we would just go in order, 67 and 82, 60s and 80s. Okay, is everybody with me? On this one, it's pretty nice because I can actually count them from here easier. How many 60s do I have? 3, so I can make 3 tally marks. How many 70s do I have? 2, so there's 2 tally marks. How many 80s do I have? 4, and how many 90s do I have? There are 9. So whether you're using a previously created stem and leaf plot or something like that, or whether you're just making tally marks as you go, that's the tally mark column. The only difference between that and the frequency column is the frequency is actually the numerical value that corresponds to that number of tally marks. This is 3, 2, 4, and 9. And I need a title. What is this title? These are grades. What was that?
Grade disbursement.
You could do the grade disbursement, or you could just say grades, yeah? For what, though? Yeah, for the second exam. So this is grades for a second exam. So it doesn't have to be those exact words, but roughly speaking, that's what we would all have written down. All right, because we've created these intervals, it lends itself very nicely into talking about histograms. Histograms are made up of adjoining rectangles or bars where the categories are shown along the horizontal axis and the frequency is along the vertical axis. Now, there's a key word here, and I would encourage you to underline it. What do you think adjoining means? Putting together. What happens if you go somewhere, maybe you guys have had this experience, and you have adjoining hotel rooms? There's a door between, and in particular, you also happen to share a wall, right? So in our case, that's where we're going to reference this. The word adjoining means that they touch each other. Okay, they're next to one another. They actually touch. So as we're drawing this, we're going to draw bars that actually touch one another. So we have our same data set we just worked with, which corresponds to this frequency diagram as well. So this grouped frequency table is a good reference point for being able to draw our histogram. So our histogram needs to start at 60 and go up to 99 or 100, whichever one kind of you want to use. It doesn't really matter. And we need to have the widths look approximately equal. So here's 60 to 70 to 80. Whoops, that's a little bit shy. To 90 to 100 or 99. It really doesn't matter. I mean, but because I've marked tens off, it kind of makes sense visually speaking for this to be in tens. The widths need to look, like realistically the same. Now, what's the fewest number in our grouped frequency table of frequencies? I didn't say that very well. How many are in that row, though? 4, 3. Is there anything fewer? 2. 2 is the fewest frequency in my table, right? Is everybody with me on that? I'm not asking the question, well, I realize this at this point. But the smallest number over here is a 2. And the biggest number is a 9. So as I'm looking at this table, I need to make sure that whatever I use my scale on the right, that it makes sense with those data values. So for instance, if I had data values that were big, like 99 and 107 and that kind of stuff, my scale will look different than if I have values like I have here, which are in single digits. So with single digits, it's nice enough to simply mark off every one unit. 2, 3, 4, 5, 6, 7, 8. And I need to go all the way up to 9, so I need it to be just a smidge bigger. 9. And again, you don't necessarily have to identify every single data value and write them all out, but you should have enough of them out that you can see it pretty well. So I'm gonna label every other. So 2, 4, 6, 8, and then I've got my 9 up there. I need to draw rectangles above the axis on the bottom, representing each height. So how many were in our frequency in the 60s? There are 3. So I need a rectangle of height 3. How many were in the 70s? 2. So I need a rectangle of height 2. How many were in the 80s? 4. And I'll draw in my rectangle of height 4. And then how many are in the 90s? 9. And I'll draw my rectangle of height 9. So the widths of all my rectangles should look reasonably the same. Okay, I mean, I don't want you getting anything like out as far as making it super precise, but it should be realistically the same. Okay? There's more here on this one that we need to label. We need a title just like the other ones, but we also have to have a label on each of the axes as to what they represent individually. So what do the values on the bottom, the horizontal axis, represent? They're the grades. And what about the horizontal, or the vertical, axis? Yeah, they're the frequencies. And then what's our title for the whole graph? Yeah, it'll look just like the frequency table that we just did before. This is grades from exam 2 or from a second exam or something like that. This is a very appealing graph. I look at it and I feel like I've seen this graph before, right? These graphs are used all over the place. I can look at it very easily. I can see, wow, I mean, like twice as many people got A's as any other grade, or more than, right? Visually, I see that immediately, and so it has a very nice visual appeal to it. Now, very similar to it, though not exactly the same, is called a bar graph. Bar graphs are much like histograms, but there's space between the rows, or between the bars. And they depict categorical data. This depicts data that's sort of, it's connected, right? You can see that the difference between an 88 and an 89 and a 90, I mean, it's all linear. It doesn't have this sort of a disconnected look to it. A really good example, I don't have this one written down, I have a different one, but a really good example would be that if you were sort of measuring like in a given class, how did the males versus the females do? Well, there's no like, oh, it was almost a male, right? But I can do that with grades. I can say, oh, it was almost an A. That A was almost a B. That I can talk about those kinds of situations because it's continuous data instead of categorical data. Now, I'm going to create some categories here because I wanted to use the same data set. But we can use the same construct that we did before, the same data that we did before, but we're going to categorize it by letter grades, A, B, C, D, specifically, instead of the numerical string of data. Because honestly, at some point at the end, and you look at your transcript, nobody cares if that 80 on your transcript was an 80 or an 89, right? It's a B. So there is some sort of sense that at the end, at least of a course grade, transcript-wise, categorical data is what we use to measure some sort of sense of how you did in a class. So I'm going to do this data that way. Okay, so it's still got the vertical and the horizontal bars, and they're still going to actually measure the same thing, grades on the bottom and frequency on the left. I'll write those in a minute. But what we're going to do is we're going to measure bars, and you can go from A down to D, or you can go from D up to A. I'm going to go from D up to A. So this is C here. I've got a column or a bar value for B, and then for A. Now you'll notice I've sort of made these double hash marks here. I'm just representing that this is going to be my bar for D, and this is going to be my bar for C. It's not really like double hash marks. I mean, it looks like it right now, but they'll cease to look like it very shortly. And I need to have my same frequency on the left from 2 to 9. So I'm going to mark those out as well. So 1, 2, 3, 4, 5, 6, 7, 8, and 9 approximately. And so how many D's did I have? Well, it was 3, right? So I'm going to do a height of 3. Let me mark them all at evens as well. 2, 4, 6, and 8. And there were 2 C's. And there were 4 B's. And then there were 9 A's. It's the same thing, they just don't touch. And it's labeled differently at the bottom to represent a category instead of an interval. And over here, I need to label my axes. Here's frequency. And on the bottom, we have grades, but specifically these are now letter grades, right? And we'll say the same thing we did before, grades on a second exam or on exam 2. Okay, so when we did stem and leaf plots, first I talked to you about a stem and leaf plot, and then I talked to you about a double-sided stem and leaf plot called back-to-back, right? Well, this is like that too. These are bar graphs, but we also have double bar graphs. Double bar graphs allow us to make comparisons in data. So we're going to use the back-to-back stem and leaf plot that we created before to create a double bar graph for the data. So you might be referencing backwards. I'm going to copy my data so we can see it all at least on the same screen together for the moment. All right, we'll go with that. It's still pretty readable. And we're going to make a double bar graph. So we're going to make our same axes that we did before. And we're going to use letter grades still because we're doing a bar graph. Intervals is done on a histogram. So on the first exam, I actually had F's, didn't I? There weren't any on the second exam, but there were on the first exam. So I need to start with F's as a location that I have letter grades. Now, the 2 bars, rectangles, for F can touch, but they won't touch the D's. All right, so this is my letter grade of F. And then I've got my letter grade for D's. And then I've got 4 C's. And then I have 4 B's, and then for A's. All right, so looking at our stem and leaf plot, how many F's total? Count them all. How many F's were there on exam 1? More.
3.
Yes, there were 3. Yeah, they actually occurred on different columns, right here and right here, right? I have 3 F's. So my frequency column, or my frequency axes, 2, 3, 4, 5, 6, 7, 8, and 9, and I'll put 10. I don't think I need 10, but there's 2, 4, 6, 8, and 10. So there are 3 F's, so I need a bar of height 3. How many F's were there on the second exam? None, so I don't need a bar there. Just leave it blank. How many D's were on the first exam? Just 1. Yep, just 1. So we'll make a bar of height 1. How many D's are on the second exam? 3. And so right next to it, touching it, I will make a bar of height 3. Should be the same height as the other bar of height 3, obviously. How many C's were on the second exam, or on the first exam, excuse me? 4. And on the second exam? 2. So a bar of height 4, touching a bar of height 2. How about on the B's? First exam. 6 compared to what?
4.
6 compared to 4. And on the first exam A's. 4. And the second exam A's is 9. All right, that's pretty close. It's not actually, is it? Man, I'm hard to get perspective on this screen. Still see the whole thing. How's that? Does it look okay? We're gonna go with it. Labeling things. So this is frequency. And this is letter grades. And this is a first and second exam. If you want to use the word comparison, we could have used that before too. First and second exam comparison. Of grades, something like that. Now there's one more cool thing that you got to do. I'm going to show you how to do it with pencil if you only have pencil with you. If you have colors with you, I'm going to do colors on my screen. So if you were having pencil with you, then what I would recommend that you do is to decide all of your first exams are going to be shaded in a specific way. So maybe you shade all of your first exams like this. And then you make a key that says that when I have this shading, this is a first exam. And then on the other one, you decide that you're going to go with shading up and down. Yours will look better than mine because you're doing it with pencil. Shading's better in pencil. And then you say that this shading that goes up and down equals the second exam. Now, if you happen to have crayons or colored pencils or markers or highlighters, which a lot of you have, because why? Why would you have those things? There's actually a really good reason. Because you're an education major. That's the reason, at least in my experience, is you could actually use those colors to mark them. So if I use orange for all my first exams, then I would write it down the same way. The orange box is my first exam. And then we're going to do another color. What color do you guys want to do? Green? Awesome. Green is my second exam. And we'll shade all the second exams in green. Isn't that pretty? Yes, I like the color too. Okay, any questions on that one? Awesome. We all need a protractor. So send these around and make sure that I get them back. I'll start one from each side. We have some calculations before we're actually able to use them and a few notes, but you'll get one as it comes around. A circle graph, or a pie chart, consists of circular regions partitioned into disjoint segments The graph shows how parts are related to a whole. Did everybody get one? Okay, excellent. So let's do the numerical calculations first, and then I'll show you how you use the protractor to help you out in a moment. We're going to use the group frequency table, I'll copy and paste it, and example 5 to construct a circle graph for the letter grade disbursement from exam 2. So, group frequency table, that's this one. All right, all those frequencies on the right-hand side were frequencies for letter grades, right? So this was the D, I had 3 Ds. The C, I had 2 Cs. The B, I had 4 Bs. And the A's, I had 9. How many total grades do I have? 18. So, you guys have been doing a fair amount of percentages and proportions back in chapter 7, and that's what we're going to use right now. We're going to take each one of these and we're going to figure out what percentage that is of the whole. Well, it's 3 out of 18, and 3 out of 18 gives me some percentage. So somebody tell me what is 3 out of 18, and we will use whole numbers. So if you need to round, round, it'll be okay. What is 3 out of 18 as a percentage? Remember, the way you do it is 3 divided by 18 times 100.
16 and 2/3.
So 17. We're going to go with 17. So this is 17%. Now, before you erase the 16 and 2/3, or the 16.6 repeating, what I want you to do next is to multiply that value by 360, because that's the number of degrees in a circle. Because what I want to know is how many degrees correspond to that percentage. And we want the decimal representation, it's an entirety, not rounded, to give me that. So if I take 0.166666666 repeating times 360, what do I get? 60 is correct. So this would give me 60 degrees. I need this value for my chart, and I need this value. And so we're going to find both of those values for all of our letter grades. So on the next one, we're going to take 2 divided by 18. And what is that as a percentage?
0.1.
Okay, and if I multiplied by 100, that'd give me 11%. Right, Hannah? And if I took that value, the 0.1 repeating, and I multiplied by 360, what would be the angle measure? 40. So again, I'm going to need the 11% and the 40 degrees when I'm done here. Now we're going to do the same thing for the number 4, and I mean, you can redo the process, but you could probably also look back up at that 11% and say, it's double that, right? Yeah, it is, 22%. And if I multiplied by 360, or if I simply doubled the 40 degrees from before, I would get 80 degrees. And again, oops, I'm going to need the 80 degrees and the 22%. The last one's the easiest one to calculate. What is 9 out of 18? 50%. And what is 50% of the number 360 degrees? 180. So we are going to draw a circle diagram that uses these measurements. Now, depending on the categories, it might not matter what order they're in. If I'm looking at letter grade categories, it makes sense to do the A's and then the B's and the C's and the D's. Like it shouldn't go A, C, B, D. That doesn't make sense. Okay, so we're going to go in order for what makes sense for our diagram. Now, I did not bring for you compasses to draw circles, but I see enough water bottles around that if you will put your water bottle carefully on your place, on your paper, and trace around it, you're going to get a pretty decent circle. And if nobody has a water bottle, borrow it from the next person. If you use the protractor, you can. It might end up being just a little bit bigger than you might want, but it would probably work okay. Okay, so you're going to draw one way or another a circle.
Okay.
Now, because the A happens to be 50%, it's really easy to draw. As you're drawing your circle, do your very best to estimate where you believe the center to be is. We're going to do our best. 180 degrees is simply half of the circle, right? So the first thing you can do is to simply draw a line through the middle, the diameter, if you'll remember that, of your circle. And this category, either the top half or the bottom half, whichever you want to do, is the A's. And there are 50% of them. So you're going to label the category and you're going to put your percentage on there. You don't need to put the 360 degrees. That's obvious because that's how we got the half circle. I'm going to do B's next. So the B degree measure is 80. Now if you'll notice on your protractor, in one direction, it starts with 0 in the inside and it goes up. And on the other direction, it starts with 0 on the outside and it goes up and around. I don't care which one you're using to measure it, but you do need to make sure that it makes sense. Okay? So 80 degrees is a smaller than halfway across your protractor measure. So whichever 80 it is that you're using, it needs to be measured from that particular point. So take the little part in the middle. Do you see the little dot in the middle where it's got like an indentation or whatever? That little dot on the bottom here goes on your center. Okay? So make sure that dot lies on the center of the circle where you've marked your center. And that the line along the bottom, not the edge of your protractor, but the line along the bottom lies along the diameter of the circle. Okay, so right now your protractor should look like it's upside down if you've drawn your A the way that I did as the top half. So is your protractor upside down? Okay, and you should mark wherever it is out there in the middle of nowhere, the 80 degree mark. So perhaps when you mark it, it is not on your picture and it's like way over here. It probably will be because probably your circle's smaller right now than your protractor. What you're going to do is you're going to connect the center to that dot. You don't necessarily have to draw it all the way to the dot, but you can use the dot as a reference point. And this would be the category for B, which was what percent? 22%. Yeah, it was 80 degrees, 22%. Here's where I wish I had like a giant protractor draw on the board so I could show you what to do. Is everybody okay with the A and the B so far? Promise we're almost done. It'll take me just 2 more minutes to finish up, okay? Your protractor still needs to be on the dot in the middle. That dot in the middle of your protractor, that indentation still on here. But now this new line that you've measured, that last line you drew, is what will line up with the bottom of your protractor, like that. Okay, so the dot's there in the middle, and then the line itself is along the side of your protractor. And as you line that up, you're going to measure again around to whatever the C value was. C value is what degree measure? Okay, it was 40 degrees. And okay, so 40 is our number, right? 40? So you're going to measure around 40 degrees on your compass. I didn't say that right. On your protractor. And the last one was 70. It was 60 degrees. I'm going to go with that as I'm eyeballing it, obviously. Here's your C then, and you said it was percentage-wise, it's 11%, right? And then the cool thing is that you don't have to measure the last one because it's the only thing left. It's the D value. If you want to measure it just to make sure that you didn't make a mistake before, you could do that, and it would be the 17% that's left.
Can we keep these for homework?
You can as long as everybody promises that you're going to bring them back to me so I don't lose them all, okay?
I have a question. Can
Yes.
you go back to the beginning of where it's a circle graph and it says the words? I don't know.
Yes, this part?
Yes.
You bet. All right, so after you've drawn that picture, you're welcome to pack your things away, and I will see you guys on Tuesday. Homework for okay, so here's the deal. That's also, I'm glad this is still recording so I can say it. Okay. I know you have a homework list from Dr. Marsh, and now I have homework at the problems at the bottom of these. Chances are pretty good they're almost identical. What I want you to do is the one that I'm giving you. Okay, so go ahead and use this values at the bottom, the group work, the homework. I know we're not doing group work and homework, so combine them in some fashion. Either put them in all in numerical order, do the group work first, do the homework second. I'll make sure I talk to the grader so that she finds all your problems, but this is your list of problems to do. Okay? All good? Thank you.